Okay, ladies and gentlemen, welcome back. If you're watching this during class, then right now I am sitting in a workshop on algebra or statistics, not quite sure, but I'm sure it's enlightening. I'm looking forward to coming back and sharing with you. Today, 12.4, properties of logarithmic functions. Since logs are the inverse of exponents, and exponents have properties, remember exponent properties, a to the m times a to the n. I can write that as a to the m plus n. And then there was another one, a to the m divided by a to the n. Then we use subtraction. So it's those kinds of ideas that we're going to be using today with our log functions. And so you can see we have an objective to apply the basic properties of logarithms, and I believe we'll give you 3 of them today. The first one is where I'm finding the log of a product. So the log base a of a product is equal to log base a of one of the terms in the product plus log base a of the other factor, I should say factor in the product. So log base a of u plus log base a of v. So let's go ahead and practice seeing how we can use that. And again, it's one of those things where depending on what we're trying to do is which form we're going to want to be able to put it in. So we need to be able to go back and forth between these two. So log base 10 of 21, can you rewrite 21 as a product? Certainly can. Log base 10 of 7 times 3. Now here in our example, 7 is u, 3 is v. We're going to rewrite this now as log base 10 of 7 plus log base 10 of 3. Now you might have noticed, and you're probably thinking that it's a mistake, that I didn't write the 10. I will tell you, much like in exponents, when I have x written by itself and there's nothing in the exponent, it's known to be a 1. Well, when you do logarithms and you don't write anything in the base, it's assumed to be a 10. So when you don't see the base written, it's base 10. So this is log base 10 of 7 plus log base 10 of 3. Now it didn't really help us simplify it any, but it's just another form for this problem. Sometimes it helps, sometimes it doesn't. Can you write log base 3 of 4x as a sum of logarithms? Put me on pause, give it a try. Okay, there it is, the sum of 2 logarithms. Alright, log base 3 of 4 plus log base 3 of x. We're also going to want to be able to go the other way as well. When you look at problem number 2 down here, I have it as the sum of 2 logarithms, and the directions are asking me to express as a single logarithm. You can see up in the previous problem, the original problems are single logarithms that I chose to express as the sum of 2 separate logarithms. Well, here I'm trying to go the other way around. So express as a single logarithm, I can only do that if the bases are the same. Aha, the bases are both base 2. So my single logarithm will be log base 2, but instead of doing 5 plus 9x, it's going to turn into 5 times 9x. And I'm taking the log of the entire thing. So I will simplify that because 5 can be multiplied by 9, and I get log base 2 of 45x. And now I've accomplished the directions, which was to express as a single logarithm. Alright, that's the idea, just being able to go back and forth between a single to a sum. And then guess what we're going to do next? That's right, division. Log base a of u divided by v is equal to log base a of u minus log base a of v. So when you see a problem here like log base c of 1/4, 1 is u, 4 is v. See if you can express as a difference of logarithms, right? Remember, difference means subtraction. Put me on pause, give it a try. I think you can do it. Alright, so log base c of 1 minus log base c of 4. Now here's a challenge. Log base c of 1 equals something. C to what power equals 1? Ah, yes. This is 0 minus log base c of 4. Don't forget, we know that log base anything of 1 is equal to 0 because a to the 0 equals 1. No matter what a is, you raise it to the 0 power, it's going to equal 1. So log base anything of 1 is 0, and then I can clean this up and simply call this negative log of base c of 4. And there's my final answer. Alright, that's it. That's the idea. And then be able to go back and forth also. So if I gave you, let me stick it over here, let's see, log base a of 5 minus log base a of 25. You should be able to write that as a single logarithm, log base a of 5 over 25. Which, yes, you could simplify log base a of 1/5. Alright, so that's the idea. You'll get some practice. Believe me, you'll get some practice. Alright, oh, this line should be moved up. This separates. There we go. Log base a of some number raised to the n power. The idea on this is that you can take an exponent in log form and you can bring it down in front. So you bring the n down in front, and now it becomes n times log base a of u. And that's really helpful when you have radicals. So let's take a look at some examples where we're going to use this. You might remember this from yesterday. Log base 3 of 3 to the 10th should equal just 10. There's not much work to do here, but let me show you how we can express it as a product. So if it said simplify, I would write 10, but it's saying express as a product. So to express it as a product, I'm going to bring the exponent down in front and get 10 times log base 3 of 3. And by the way, do you know what log base 3 of 3 is? It's 1. 10 times 1, because 3 to what power equals 3? So you can see how I get the same answer. But since it's asking me to express it as a product, that would be my answer, 10 times log base 3 of 3. When you see radicals in log form, you're almost always going to want to put it into a rational exponent. So first thing I would suggest is rewriting square root of 5 and rewrite it as 5 to the 1/2. Now I can write it as a product by taking that exponent and bringing it down in front, and I get my final answer to be 1/2 times log base a of 5. And that's it for bringing the exponents down in front. So we just learned 3 different properties. We learned the when you have a product, you can express it as the sum of logarithms. When we have a quotient, you can express it as the difference of logarithms. And when you have an exponent, you can express it as a product. Okay, so what I want to do now is kind of put it all together. And we get a problem like this. Log base 2 of the cubed root of 5x squared over y to the 4th. And the directions are expressed in terms of logarithms x, y, and z. That implies multiple logarithms. And right now we have one logarithm. So I see I have a product, I have exponents, I have quotients. So I'm going to have multiplication, addition, and subtraction all in this problem. So let's take it step by step. Alright, first thing is take the radical and write it as a rational exponent. So this is log base 2 of 5x squared over y to the 4th raised to the 1/3 power. Alright, I am going to take that 1/3 and I'm going to bring it down in front. 1/3 times log base 2 of 5x squared over y to the 4th. Okay, so this 1/3 now is being multiplied by the entire logarithm, and so it means I'm going to start using brackets. So I have 1/3 times, let me take this division and turn it into subtraction. Log base 2 of 5x squared minus log base 2 of y to the 4th. Alright, stay with me. Okay, so I'm close. I have this exponent here, which I'm going to bring down in front. I have an exponent here, but before I do that, I'm going to rewrite this as a sum, because right now it's a product, so I'm going to expand this out. So I get equals 1/3 bracket log base 2 of 5 plus log base 2 of x squared minus 4 times log base 2 of y. And now I'm almost done. One more step. And the last step is to just bring this 2 out in front, and then I'm going to be done. I could distribute the 1/3 in if I wanted to, but I'm not going to. 1/3 times log base 2 of 5 plus 2 log base 2 of x minus 4 times log base 2 of y. And now I've satisfied the directions, which said write or express in terms of log x, log y, and log z. There was no z. Alright, so no z on that one. Ah, there's a z in the next one. Okay, take your time. Give this letter B a try. You see I have a quotient, so I should have subtraction in here. I'll give you a hint. It's divided by x times y, the quantity. I have a radical, so I'm going to turn that into 1/2 and bring the 1/2 down in front. And I'll have a 3 here, so that'll end up having to come down in front also. And all of these will have log base A. Give this one a try. Pause. Now. Pause. Okay, let's see how you did. Square root can be written as a 1/2 power, so that's the first thing I did. Next I moved that 1/2 down in front, and I have 1/2 times log base A of z cubed over xy. So now I'm going to take this division and write it as subtraction. 1/2 times log base A of z cubed minus log base A of xy, and remember that's the quantity xy. That's going to become important in the next step. So I see I have x times y, so I'm going to take this and write it as the sum of logarithms. So the 1/2 carries down. I also took this 3 and wrote it out in front, so I have 3 times log base A of z minus, now I'm writing this as the sum, log base A of x plus log base A of y. Take your time and process that. Okay, the 3 came down in front, x times y became log x plus log y. Now what I'm going to do is I'm going to distribute the negative through the parentheses, and I get minus log base A of x minus log base A of y. And then lastly, last time I didn't do it, this time I did. I'm taking the 1/2 and I'm distributing it to each of these 3 terms. So 1/2 times 3, 1/2 times -1, 1/2 times -1. My final answer looks like this. It's a tricky one. That's one I would practice again until I could get it right, in case you didn't get it right the first time. I don't expect you to necessarily get it right the first time, but I do expect you to practice it. Alright, let's see what we have left. Alright, now we're going to go the other way. Now we're going to go from multiple logarithms. You see I have 1, 2, 3 terms here, and I want to express as a single logarithm. In order to do this, I would start by taking the numbers out in front, the coefficients, and writing them as exponents, and then turning those back into radicals. Taking addition, writing it as a product, taking subtraction, and writing it as a quotient. So here's how it looks. How much time do I have left? Okay, I have about 1:45, so I'm going to kind of pause and do one step at a time without talking. Okay, so my first step, just took the coefficients, made them exponents. 1/2 goes to the exponent, 2 goes to the exponent, 1/3 goes to the exponent. Now I'm going to take the plus and write it as a single logarithm. Okay, so I took the sum and I wrote it as a product of one logarithm. Ooh, this should be minus. That's going to be minus, and now what I'm going to do, not that. Now what I'm going to do is I am going to, it should be minus, this is back to A. Now what I'm going to do is I'm going to take the subtraction, write it as a single logarithm based on division. Alright. Okay, so the subtraction became division. I also took 9 to the 1/2 power, which is the square root of 9. Made that 3 over here. I took 5 squared, made that 25, and 125 to the 1/3 is the cubed root of 125, which is 5. So I'm going to simplify that to 5 also. But I'm just about done. See if you can simplify this all the way down. See you in a minute. Alright, 3 times 25 divided by 5 is 15. So we end up, after all that, with log base A of 15. And remember, none of this would have been possible if all the bases up here at the top weren't originally the same as each other. Because they're the same, we can do this. Alright, your try. Log base A of x squared minus 4 minus log base A of x minus 2 expresses a single logarithm, and simplify. Check back with me when you're done. You might have to factor here to simplify. Alright, subtraction became division. This can factor. If you see over here, the x minus 2 is cancelled out, and I was left with log base A.